The next rule that we're adding to our toolbox is called the quotient rule. So as the name suggests, it's when we're looking at differentiating something that is in a fraction, okay? Quotient means division. So if I give you that y is u over v, so we're still using u and v as our notations. So u is the numerator, v is the denominator. Then when we write out the formula for the quotient rule, so if I want to find the derivative, it looks like this. Now it looks quite intimidating, but it's okay, we can do this. So dy dx is v du dx minus u dv dx over v squared. So the d notation does get quite clunky. Unfortunately, that's the one that's given on your reference sheet. But if we write it using the dash notation, I can write y dashed is v u dashed minus uv dashed over v squared. Okay, so the du dx we can write as u dashed, dv dx we can write as v dashed. So we've got vu dashed minus uv dashed in the numerator over v squared. Now, if you remember from your product rule, I wrote the product rule as vu dash plus uv dash. Okay, now you can see why I've chosen to write it in that order. Because when it comes to the quotient rule, you're subtracting these two terms. So the order of them is really important. So if we can remember the product rule in this order, then we're also doing the quotient rule in exactly the same order. The only difference with the quotient rule is it's a minus and it's over a v squared. Now I've only got one example for you for this section, only because I want you to get straight into practicing the differentiation process. So when we're looking at this function, so just one quick one, 3x over x squared plus 1, then the numerator is u and the denominator is v. Again, we want to see you writing all of this out. So u equals to 3x, v equals to x squared plus 1. So we're going to differentiate to work out u dashed and v dashed. So the derivative of 3x is 3. X squared plus 1 turns into 2x. So those are our derivatives. What we're now going to do is substitute it into the quotient rule. So vu dashed minus uv dashed over v squared. So numerator, we've got x squared plus 1 times 3 minus 3x times 2x, all over x squared plus 1 squared. We're going to expand and simplify the numerator. So if I expand the 3 in, 3x squared plus 3 minus 6x squared, and that's all over x squared plus 1 all squared. We need to collect like terms. The x squareds are like terms, so we'll bring those together. So that's 3 minus 3x squared over x squared plus 1 all squared. If we want, we can factorize that. 3 is a common factor in the numerator. So 3 bracket 1 minus x squared over x squared plus 1 all squared. If we want, we could go even further. 1 minus x squared is a difference of squares. But for what we need here, we can't really do much more with it because we can't cancel with the denominator. So it's fine to leave it like that. I will factorize it just for completeness sake. So 3, 1 plus x, 1 minus x over x squared plus 1 squared, and that's going to be your derivative. Again, here I've just shown you how to differentiate. You can also do all of this differentiation in conjunction with our tangents and normals things. So the worked example in your textbook does do a little bit more with like finding when the tangent is horizontal. Some of your textbook exercise questions will also be asking you to find the gradient, find tangents, and find normals as well. So it's the same process as what you were doing in that the exercise earlier on tangents and normals. Now, with these questions, it is quite a short exercise. Work through these questions. This question 9 that I've highlighted here, it's actually part of the challenge bit, but I'd like you to have a go at it. What it is it's bringing all these ideas of your normal differentiation, chain rule, product rule, and quotient rule, and you want to look at each of the functions and work out which is the best method to be using, because sometimes one method will be much more efficient than another one. In the end, it doesn't matter which method you use as long as you get the right answers out of it. Um, but it is a good exercise in sort of looking at something and thinking, what's the fastest, what's the most efficient way, what's the most accurate way that I can use to solve these problems. 6 to 8, have a go at if you feel like you need a bit of a challenge, or if you finish the work and you want to give a couple of extra questions a go.